Hello everyone, welcome to my video about the types of graphs that you should do for your analysis when you have a data set. If you remember my first video, so a data set is composed of contains columns that are what we call the variables, and the rows represent usually the participants. So when you send a survey or when you collect the data from several participants, usually each row will represent a participant and the columns will represent the variables that you should use. After that, you have different types of variables. So two main types of variables that you should remember, absolutely. The categorical variable. So for example, gender is a categorical variable. It is moreover nominal variable because it takes values, it takes names as values. For the gender, for example, it's either a male or a female. The favorite animal, for example, this patient would like, if I had to add a column favorite animal would be a nominal variable, which would be dog, cat, or snail. It depends. You have here you would have the choice between three values in that categorical variable. So in the categorical variables, these are mainly what we call the qualitative variables. Okay, here we have the gender only, that is categorical. All the other variables in this data set are numerical. So they can be either continuous or discrete. We treat like age, body weight, height, and blood pressure as continuous in that case, okay? The discrete variable is more like the number of, it has to be an integer. Behind the variable age, we think that we can be 60.5 years old. It's not like you're either 60, exactly 60, or 61, exactly 61. So that's why age, for example, will be treated as a continuous variable. If that's the number of sandwiches sold at this store, if that's the number of sandwiches sold, then that can only be 1 or 2 sandwiches sold, okay? Not 2.5 sandwiches sold. Well, we assume that the sandwiches are not cut into two parts, of course. The number of bikes sold in this store, number of items in general sold in a store, or number of students who come to the lecture per day, would be a discrete variable, okay? In the categorical variables, I haven't talked about the ordinal variables. So these are mainly Likert scale variables. So these are categories, but with a meaningful order. So you can split a continuous variable, for example, the age range, into different categories with a meaningful order. For example, people of less than 30 years old, people between 30 and 60 years old, and people above 60 years old. In that case, you would have categorized the numerical variable age, okay? The continuous variable age would have been categorized, okay? But there is a meaningful order. There is the number 1 is people less than 30, number 2 people between 30 and 60, and number 3 people more than 60, okay? So an ordinal variable is usually categories with no more than 7 levels with a meaningful order. After 7 levels, you can start to treat it as a numerical variable, but you will have converted all these words into into numbers, okay? So categorical or numerical. Now, what would you have to do if you have a data set, some research questions? Well, first of all, you need to do a data exploration, okay? By data exploration, it means that you should explore the columns of your data, how many males and females you have among your patients, what is the distribution of the age, is the average age coming to the hospital, for example, in that data set, more than 50 years old, and so on. You will need to graph, to explore, to use tools in order to visualize better your data, your variables, and so on. The number of patients as well, and so on. So depending on the research question that you have, you may have just to look at how is distributed a numerical variable. And in that case, you would use this well, this classification, for example, classification I just made for this video, but you can use another classification, it's up to you, of course. But I wanted to summarize where should you start, okay? If you don't know anything at all about your research question, just analyze column by column. Try to find association between two different columns, that is, two different variables. Or try to see the distribution of the categorical variable or the distribution of the patients, okay, like their age, as I said. So when you have to deal with a numerical variable, for example, let's say you would like to know what is the distribution of the age, for example, you would represent it in a histogram or a box plot, and I will explain these two notions in my next video, distribution of a numerical variable 1.1, video 1.1, which is indicated in that PowerPoint. So I would basically explain to you how you represent a numerical variable, how you can represent the distribution of a numerical variable. So you would use a box plot or a histogram, okay? If you don't know anything like what to start with, you start by data exploration. And if you don't know, like if you don't have any idea of what association you're looking for, you just explore each possible association that you would like to see, okay? Otherwise, if you have your proper research question, I would like to know what is, for example, the association between blood pressure and the height. In that case, I would have a look, since blood pressure and height are two continuous variables, right? Height is continuous, blood pressure is continuous, remember, variable. So height is a variable, it's numerical, it's quantitative, and it is continuous, okay? We consider it as continuous because it can be 150.5 centimeters, okay? And the blood pressure is also continuous. So this is also a measure of the blood pressure, okay? So in that case, you would have a look at this table, and you would have a look at, for example, association. It's not, for example, you have two numerical variables. You want to look at the association between two numerical variables. So you go to that row here, sorry. So the row association between two numerical variables, you would do a scatter plot to illustrate this association, okay? A scatter plot, which is indicated here. So the y-axis will be, for example, the height, and the x-axis would be the blood pressure. And you would see if there is an increasing, like a trend or not. So if there is a trend, it means that they would be related, okay? They would be associated. The statistical test that you would use is the correlation coefficient, either Pearson or Spearman. We will see that in the video 1.4, correlation between two numerical variables. Okay, so that's an example. Now, for example, you want to look at the distribution of the gender in that data set of patients. So in that case, you would have to you would have to go to that row, distribution of a categorical variable, and watch the video, distribution of a categorical variable, because it will help you how to represent the distribution of the age in a hospital. So we would do a pie chart. It's quite good because it's in terms of percentage, okay? Or the bar chart. So in the bar chart, you have to be careful because you would represent the counts, and you have to be aware that when you represent by counts and not by percentage, okay? The percentages represent more the distribution, okay? Because with counts, we can be impressed by big numbers, but if the other category has also big numbers, it's not really informative. So you need to put percentages rather. I mean, I would advise you to put percentages. So the statistics, the descriptive statistics that you would use, for example, actually, as I said, is the percentage per category, okay? This is, you can also explore the count per category, but the percentage per category is important. The mode, so I will come to that in my later videos. for example, in the video distribution of a categorical variable, the mode is the most frequent category. So if you have more males than females, it would be male the mode. Okay, the mode is the value of the category. So the categorical variable gender has values male or female. So male is the most frequent category in that data set. Let's say it's the male. In that case, the mode will be male. The mode of the categorical variable gender would be male. Okay, I will re-explain this later. So you want to look at the distribution of the gender in that hospital or in that data set about the hospital. You look at row 2, distribution of a categorical variable. If you have to look at the association between two categorical variables, then what we usually do is we represent it by a clustered bar chart or a stacked bar chart. I will come to this in the video 1.3, association between two categorical variables and chi-square test. So the count per cross category. So you want to look at the association, for example, between gender and survival on the Titanic. So a cross category would be, for example, male survived. So that would be a cross category because it's crossing the category, a category of the first categorical variable, that is gender, with the category of the second categorical variable, which is survival status, which is survived. Okay, so you have 4 cross categories in that case because you have 2 binary variables, 2 categorical variables. Each of them can take 2 values, so they are binary. We call them binary. Okay, but if they have more than 2 categories, then if a categorical variable has more than 2 categories, it would be not a binary variable. It would be, we would call that a nominal variable, and that's it. So survival versus gender, you want to look at if there is an association between the survival and the gender. You would put your cross categories, okay, and you would count per cross category. You would get the percentage per cross category, and then you would have a look at the clustered bar chart and the chi-square test in order to conclude if there is indeed an association between two categorical variables. Video about the test, the hypothesis testing. So in that video, I explained the p-value. The p-value less than 0.05 makes you reject H0. So in each statistical test, you will have a H0. The chi-square test, you will have also a H0. Okay. So sorry, I was talking about the association between two categorical variables, which is the third line. Okay, this one. So the chi-square test will use a null hypothesis of no association. You get the p-value, p-value less than 0.05, you reject the no association. So it means that there is a significant association between gender and survival status. We will see that in the video about the association between two categorical variables. Okay? So association between two numerical variables. So I already talked about this. In that case, we do a scatter plot and a correlation coefficient with there is a p-value associated to it. So we will see that in the video correlation between two numerical variables. Okay. Now, association between one numerical variable and one categorical variable. So that one is when, for example, you want to look at the difference of height between two groups, between males and females. So in that case, if you see a difference between males and females, what it means is that there is an association between the numerical variable height and the categorical variable gender. Okay? It's exactly the same as measuring the association between this numerical variable and that categorical variable. Saying if there is a difference between the groups of a numerical variable, if the height is different between 2 groups or 3 groups, it is the same thing as saying that there is an association between the numerical variable height and the categorical variable group. Okay? The statistics that we use, so we will see that, would be the mean, median, mode, and the graphs that you would plot would be multiple box plots or line plots with each center of the line representing the mean or the median. Okay? You would represent usually the mean when your data is normally distributed per group. If it is not normally distributed, you would represent the median. The mode, it's a bit rare. You need to you need to model your distribution like you see in the histogram above. So in the histogram here, you would see, for example, the mode if you model this by a curve. So the software will do it, and by software I mean R. I will go through some Python coding as well, but in the first videos I treat here, it will be done in R and ggplot. Okay, so R will find the best curve, so the curve of best fit. This is a Gaussian function, so well, at the moment let's not go into details, but the mode would be the peak, okay, the value on the x-axis where you have the peak, the summit, okay? Not sure if we can say summit, the peak of the mountain of the Gaussian function. That would be the mode, okay, in a continuous context, in a continuous variable context, okay? At the moment, let's just focus, it would be the mean or the median per group, per time, or per group, as you wish, okay? Same thing, we can get the Q1, so we can get the Q1, looking at the box plot, the Q1 per group, okay? That would be the bottom of each box. We will see that in a video, distribution of a numerical variable, 1.1, how to read a box plot. This is very, very important. Q3 is the top of each box. So like by Q3, in fact, it means 75% of this group have their values below Q3, okay? Below this. We will see that again in distribution of a numerical variable. Q3 is 75% are below Q3, 25% above Q3. Q1 25% below Q1 and 75% above Q1, okay? IQR is the interquartile range. So standard deviation, Q1, Q3, IQR, minimum and maximum. This is more to look at the spread of your data, okay? By the way, the range sometimes is used, and the range is simply maximum minus minimum, okay? That's the distance between the minimum and the maximum, okay? So per category in that case, because we look at the association between a numerical variable and a categorical variable. This will be seen in the comparison of a numerical variable between different populations. It would be just about descriptive statistics, but the tests that derive from them are simply the independent t-test and the one-way ANOVA that we will see in another video, okay? It will come to my channel quite soon. So remember to go to that table if you have no clue of what to do, of how to represent the association between two variables, how to represent the distribution of a particular variable. And as usual, if you have any comment or question, you're welcome to send me an email and I would be more than happy to answer to you. Okay, so get a grasp at this slide, try to digest it, understand it, and we can talk about it maybe in one-to-ones if you contact me in my email below. Okay. I wish you a very nice day or a very nice night if you're watching this video in the evening. Yeah, you're more than welcome to join the course and the other videos as well. Okay, see you soon.